All right, good morning, everyone. So now that we've got this technical issue, it's something strange that's happened a few times, but now that we got that taken care of, let's complete our initial discussion on normalization. Let me make sure, yep, that's what we're working on. All right, so I want to make sure we're not too far ahead or too far behind. We are quite a bit ahead, actually, now that I'm looking at the schedule. What we're going to do is we're going to finish off our intro to normalization. Again, because what we're doing here with these slides will basically give you everything you need to know for your group project. Then what we'll do is I'll do this and I'll do an example today. And then I guess the following week, one of the things I'll want to do next week is a midterm review so that we can prepare for the midterm. Actually, wait, your guys' midterm is the first week of May, not the last week of April. We'll finish off all of normalization next week, but we'll do some examples as what we'll do. And one of the things I will do as part of the example, yeah, that's right, next week is I'll show you how to take our example that we're going to do in a moment, how to take that and bring it into a MySQL database and do some of the queries that we were talking about, the create table queries, the insert into queries, and all of that. Okay, all right. But first things first, let's see. All right. I think I may have mentioned this yesterday. If I didn't mention it in this class, I mentioned it in my other class. But Grace Hopper, you may recognize her name from previous quotes. She was the inventor of the first compiler. She was a rear admiral in the United States Navy. And she basically, before she invented the first compiler, all the really smart people, all the people who knew computers really well, said the only thing a computer will ever be will be an adding machine, will be a mathematical machine, and that basically it would never do things like run programs. And so basically that's kind of what our quote is all about today from her. Is the most dangerous phrase in the language is we've always done it this way. Always be concerned if someone says, I can't do it any other way because it's always been done this way. All right, that be on the lookout for solutions that challenge the way that we've always done it. Now, that's not to say that new solutions are always better. That's not it. It's just if we lose the ability to try to consider alternative solutions from the way it's always been done. Someone said the way we've always gotten from one city to another is using horses. And that's the way it's always been done. There's no other way. But now we have cars and now we have planes, right? So someone had to challenge how communication could be done. We've always just sent letters. There's no other way. There's no other way for me to communicate with someone in another city. Just been sending them a letter in the mail. But now we have phones. You guys, some of you are in a different city from me right now, and we are able to have this class, right? So always be on the lookout for new ways that challenge the way it's always been done. Okay. Did I get lost somehow? What happened? Okay. All right. Now, the process of normalization. Let's talk about that. All right. So we talked about yesterday, we talked about functional dependencies. Make sure that you know these terms, okay? Because I will plan to give one more quiz before the midterm. What I'll probably do is I'll put the quiz next week because I know some of you, you're in the first year or the third year classes, so your midterm is going to be the last week of April. So I won't put a quiz on the same week as your other midterms. So don't worry about that. I'm not that cruel, I don't think, but I won't do that. So I will, so I'll give a quiz next week. Basically, whatever day I gave the quiz last time, I'll give it on the other day this next time. So I can't remember if I gave it Wednesday or Thursday last time, but there's date stamps on when you guys took it, so I can look that up. So whatever day it was that I gave it last time, it'll be the other day this time. Okay. But for that quiz and also for the process of normalization, I need you guys to know a few terms. Okay, so you need to know what a functional dependency is. What a full functional dependency is. What a partial dependency is. And what a transitive dependency is. Okay, so you need to make sure you know what those things are, okay, and how you can identify them in a data set. Right. Now, the way that we get from our sources and all of our different sources of information that we're going to bring into our database, the way we get from there into a third normal form database is we're going to give take our attributes and put it into a table format. Okay. Now, it doesn't mean that each individual cell has to have a single value. A normalized form can have some cells have more than one value. In fact, we're going to see in the example data that I have an example of that. Okay. Now, we're going to remove repeating groups. Okay. We're going to and that's going to get us into our first normal form. So now the first normal form is basically going to look a lot similar to our unnormalized form, where every cell will have a single value. Also, the first normal form, we will want to have identified a primary key for our table. For most of you, very, very few, I think, would have more than one table in the first normal form, but some of you might, but very few would have more than one table in the first normal form. And once you get that first normal form, if you identify the primary key for that table, okay, then you have a first normal form database. All right. Then we are going to remove partial dependencies, and we'll talk about how to do that. So a second normal form database is a database that is defined as being in the first normal form, but there are no partial dependencies on any of its tables. Okay. So I guess I should say rather a table that is in the second normal form is a table that is already in the first normal form and has no partial dependencies. What will likely happen in order to remove our partial dependencies is we will create a new table. All right. And we'll move the data over to there. So kind of like the staff branch, but that was actually the transitive, but we'll talk about that too in a second. All right. So we'll take our data from our first normal form, we'll move it into our second normal form. There will be no repeating lines, no repeating rows, and yeah, and that table will have no partial dependencies either. All right. A third normal form table is one that is already in second normal form, and we've removed the transitive dependencies. So there's no transitive dependencies in a third normal form. A second normal form database can have transitive dependencies, cannot have partial dependencies. A third normal form database will not have transitive dependencies or partial dependencies. Okay. All right. So again, we have a table that contains one or more repeating groups as our unnormalized form. Basically take the data from the source from a form or from whatever, and we're going to put it into a table format with columns and rows. Okay. how do we get from first normal form, from UNF to first normal form? In a 1NF table, the intersection of each row and column, so each cell has one and only one value. Okay. All right. UNF to 1NF. So how do we get from the unnormalized to the first normal form? Right, we are going to have an attribute or a group of attributes, likely a group of attributes. A single attribute being a primary key would already then basically get rid of, would automatically move this into second normal form already because there would be no partial dependencies. All right. So we're going to have an attribute or a group of attributes to act as the key, the unique identifier for that table. We're going to identify the repeating groups, right? So the ones that repeat for the key attributes. We're going to remove the repeating group, right, by separating it out into other rows, right? It's called flattening the table. We'll see an example. I think there's an example in this set of slides. But if not, then I'll show you my example. Okay. Right. We can also place the repeating data along with a copy of the original key into a separate relation. Right. This one's going to be fairly simple and straightforward. If when you brought your data into the unnormalized form, you already put your data in the format of every single cell having a single value, you're already mostly there. You just need to identify a key. Basically, is what you need to do. Okay. So the second normal form, right? We need to have all of our tables in our second normal form. The primary, there is no partial dependency there. Okay. If A are attributes of a relation, remember B is fully dependent on A if it's functionally dependent, but not on a subset of A. All right. All right. This should read actually A and B are set of attributes or sets of attributes of a relation. Okay. So any relation that is already in first normal form and every non-primary key attribute, so any attribute that's not part of the primary key, is fully functionally dependent on the primary key, that's second normal form. This is why I said that if you have a single column that is your primary key of your first normal form database, it's already in second normal form because it's not possible to have a subset of a single column. Okay. So how do we get from 1NF to 2NF? We say, what is our primary key for the 1NF? We identify the functional dependencies in that relation. If there are partial dependencies that exist, then we remove them by placing them in a new relation along with a copy of their determinant. So basically we take the column that it's partially dependent on, the determinant that is partially dependent on, right? We place a copy of that into the other new relation along with those columns that are dependent on the determinant. Okay. Again, a lot of this is going to be a lot easier understood through an example, so I'll get through the slides hopefully pretty quick, and then we'll talk example after that. All right, finally, we want to get to the third normal form. Transitive dependency. If A determines B and B determines C, then we can say that C determines B. Sorry, C. If A determines B and B determines C, then we can say that A determines C, or what I was trying to say before I messed it up was C is transitively dependent on A through B. Okay, so what we can do is just like we did with the partial dependency, is we take a copy of B, right, and make it the primary key of a new relation, and we take the C columns and we put them over there too. Okay. This was the example of a transitive dependency we talked about was the branch. The branch number determines branch address from the staff branch table. And notice that what happened was we created a separate branch table. There's going to be a lot of confusion, I think. Well, what's the difference between partial dependency, transitive dependency? In both cases, we take a copy of the determinant, we put it in a new relation, we take all the columns that are determined, we put them in that new relation to, we did the same thing twice. Why is this two separate steps? So the reason for that is because one of these is the partial dependency, meaning that it is based on that a column is dependent on a part of the primary key, but not all of it. It's all about the primary key in that situation. This one is transitive dependency. It's a little bit different in that it's not about the dependency being on the primary key itself or a part of the primary key itself. It's still fully functionally dependent on the primary key. It's just that it's also now dependent on some other column that's not even part of the primary key. Right? Okay. All right. So how do we do that? Same as, like I said, same as before, is we identify the primary key. We identify the functional dependencies. If there are transitive dependencies that exist, we get rid of them by placing them in a new relation with a copy of their determinant. Determinant. There's a lot of typos in this set of slides. Okay. All right. A relation that is in the first normal form and there are no partial dependencies, that's second normal form. A relation that is in both first and second normal form and there's no transitive dependencies, then that's a third normal form. Okay. So I guess the example might be part of the other set of slides. Let me take a look real quick before I pull up my example. Yeah, this could work. Okay. We'll go over this one again next week too, but I do want to go ahead and but it's a little bit fuzzy, but hopefully you can make it out. All right. So here, notice that this cell has more than one value. Now we can look at this, right? We can look at this table here and say, well, clearly 18th of October goes with 10 o'clock, goes with this comment, need to replace crockery, goes with this staff number, all that. We can look at that and say this goes together, right? But a computer will just see this as text, right? As three pieces of information in the one row, right? In the one row has three pieces of information here. So what we would need to do is we would need to separate this out. And what I mean by that is, let me get a pen going, is we would need to kind of all right. Now, for these columns here, property number and property address, right? What we would need to do is we would need to put a copy into each of these rows, this value here, because what we understand this to be, when we look at this, PG4, PG16, okay? What we understand this to be is that PG4 at 6 Lawrence Street on this date had this inspection. PG4, even though it's not, shows that doesn't show up in this row initially, again at Lawrence Street, on this date had this inspection, and then PG4 on this at this address on this date had a different inspection. That's how we would read that, right? But the computer can't know that, so we have to fill in this into each of these other spots as well. Okay. Now down here, right? There's no. I guess they did this for me here. They just didn't draw the lines. Right. So notice this is the same thing as what I just did above, but without the lines drawn. That's why I didn't really understand that it was the same thing, because the lines aren't there. Right. So this would be our unnormalized form. This could be our first normal form if we identify a primary key. So let's do that. Let's identify a primary key. Help me out here, guys. So let's see. I'm just going to label these A, B, C, D, E, F, G, and H. Okay. What are some dependencies here? What are some functional dependencies you can see? You say F determines G. Yeah, the staff number determines the staff name. Sure. You know what? I think I can do this actually to help myself out. One second. Okay. I think I might could. Where are you, text? It does work. I couldn't do it. Okay. Sweet. So let's do this then. Sorry for the technical hiccup here, but this is probably going to be better for you to read, actually. All right. So let's see. What was your response? Oh, you guys got a lot more responses. Okay. F determines G. Staff number determines staff name. Yep, I'll go with that. F determines E, you say. Good. All right. Okay. Someone else said A determines D. Yeah, property number determines property address. Great. Somebody else, let's see. And D determines A. Yes, Arjun, you're correct. But let's, for this exercise, let's deal with the ones that are most likely to hold for all time, right? So staff number determines staff name is probably more of an all-time type of thing, right? Okay, so, ooh, you're getting into a big one there. F, B, C determines A. Ooh, let's see, multi-column one. Let's see, F, staff number, date, and time. Yeah, I mean, I could see that, right? Like, because what that implies is that a particular staff person on a particular date at a particular time can only be at one property. Yeah, I mean, I can't be at two places at once. I mean, maybe in the Marvel multiverse we can do stuff like that, but here in real life, BCF, yeah, let's call that one. I like that one. FBC determines A. Do we have every column now? A, B, C, D. Oh, we're missing E. What's E? Or how can we fit E in something? Ah, good question. Car registration. Okay, car registration is, this is some of our staff are being given cars to use to go out to these places. Since we're asking them to go inspect the property, we're not going to make them use their own personal vehicles. So we have company vehicles, and this is the license plate number that it's going to use. At least that's how I think it, that's what I read it as. And notice that like N721 HFR is the same car, all right? Okay, so F determines H. Does it? Does F determine H? Let's take a look where you have the same F. Does it always result in the same H? SG14. Well, I mean, here it does, and SG14 here it does, but here, ooh, no, that's a problem. All right, so we can't say F determines H. Can't go with that one. So, but a date and staff number determines H. That's true in this current data, but do you think that's going to hold for all time? Is it possible that a staff person could go out in the morning to inspect a property in one car, come back, and then go to a different property in the afternoon with a different car? Yeah. I think maybe we might use what we already have. That. Oh yeah, Eileen, you put it there a few minutes ago. This BCF that determines the property number kind of also determines which car they use, right? So yeah, so what we could do is we can just add. Okay. What about E? We're missing E, right? How can we get E involved? Did anybody write that and I missed it? Oh, Zara setting, you said H determines A, B, C, D, E, F, G. Okay, so you're thinking H would be the primary key in this situation, but does it? Let's see. This car value M533HDR, is it always David Ford? Yes. Is it always SG14? Yeah. Oh, wow. Good so far. Is it always 22nd of April? Yeah, actually it is. Look at that. Is it always 9 o'clock? No. Is it always PG for the property? No. Okay, so H can't determine those things. Okay. So Kershad, you're saying the combination of A, B, C, and F determine E. Does that require A? Because if B, C, and F determine A, which you said that above, right? Yep. If B, C, and F determine A, then do we need A for it to determine E also? Because if B, C, and F are a staff person on a particular day and time, right, they would have comments about that particular property. So I'm thinking that what we would have here is B, C, and F, B, C, however you want to order it, determine A, H. This is my thought. Mark it down. A, H, and E. This is just my thought. Okay, but what you'd have with the A determines, not A determines E. Yeah, with the example, yeah, it could have been a partial dependency, but no. Okay. So this is some examples of some dependencies that we have. Let's take a look at the ones that they have prepared for us. Okay. So they actually put one that's quite a bit different for their primary key. They put this as what they think a primary key could be. That the property number on a specific date. So their idea is that a property number is only inspected once per date. That might be that's a reasonable idea, right? Unless, what if we don't trust David Ford? We don't trust David Ford that he did a great inspection. So after he goes out to a property, we're going to send Ann afterwards to make sure that he did a good inspection. Maybe. All right, we'll stick with this though for now. All right, so they're saying property number and date results in all of these other values here. Now, some of the ones that you guys noted here are partial. This would be a partial dependency. If this is our primary key, then our partial dependency would be property number and address. A transitive dependency would be staff number and name. They do give us some alternative. Where are you? There it is. An alternative candidate key. Oh, actually, this could be also a transitive dependency, maybe. In that it's date and staff number, car registration. Okay, so one of you actually said that, and I said there was a reason not to do it that way. You guys agree with the slides, not me. All right. And then an alternative candidate key could be the date and the time and the car. An alternative candidate key could be the date and the time and the staff number. And I think that's BC. Yeah. So this was our other candidate key that could be our primary key, right? But it's all, which one's the primary key, which one's the candidate key, is all dependent on how we look at it. So again, if we say that a property can only be inspected once on a given date, then yeah, this makes sense for a primary key. If we say it is possible that two different inspectors could go out to the same property on the same day at different times, then this would no longer even be a candidate key, right? Because this would no longer uniquely identify this row. We'd have to add something like time in, or we'd have to add something like maybe staff number, because we assume that the same person won't go back out and inspect the same property twice in a given day. Right, so this would be one of those things. Whether or not this serves as a primary key is what we would call a design decision that would be based on communication with our customer. This would be one of those things where we would say, oh, this makes sense. But our customer might be like, no, I want like properties to be inspected more than once on a given day in case, you know, some of our employees aren't as good as others. All right. All right, so we've run up against very close to a break time. So let's do this. Let's break here, and unless there's any questions, and then we will come back from the break. And I have prepared a fun for me, example for us to go through, for us to see how to identify dependencies in a given set of data. Okay. All right. See you guys in 10 minutes. And well, unless there's any questions, comments. Okay, Let's talk in 10 minutes.